Hello, Professor. This is Alberto Martinez with the demo for Project 3. So to start off with our main, we set up PLL to be 80 MHz, which is the system clock of the TM4C123, followed by initializing UART1 and 5. So UART1, if we look here, is PC5 and PC4, and I'm using it to communicate between the two TM4C boards to transfer the DAC data, the DAC values between the two. And we're setting the baud rate at 57,600 with even parity and one stop bit. With that said, we're also initializing UART5, which is able to communicate between the first microcontroller and the Bluetooth module, that is PE4 and PE5. Same baud rate of 57,600 and 8-bit word length, even parity and one stop bit. So once those are set up, we initialize the SysTick and we set the PWM as getting it started. And we're going to output these strings here, just kind of like for the title of the project, to show on our serial terminal using UART5. So it's being transmitted with the Bluetooth module. So once we get into the while loop, we're going to ask for a char from the actual serial terminal, and it will be saved in here and go into the switch case. So if the case is a B, we will output PWM value to the first microcontroller, and if the value is, or if the case is an F, we're gonna output the DAC value onto the second microcontroller from the first. Or if it's anything else, we're just gonna say that it's failed and it's gonna return back to the top. So the way we're handling the PWM case, we are going through UART5, asking for a value between 0 and 255, and we are taking that value in from the serial terminal into the Bluetooth module and receiving that value on the TM4C board, taking that value and setting it to change the duty cycle of that PWM accordingly. Our PWM in this case is used in PF2, which is the blue LED, and it has PF2 PWM. Yes, it has the generator A, it has reload of the duty of, I believe I have it at half the speed of the actual board, so 40 megahertz, in order to make it a little bit more power efficient, and as well as enabling this bit every single time that it kind of runs through. Along with that, we also have this function that is the one that actually changes the duty cycle every single time according to that value of 40, and we're initializing it a little lower just so that the brightness is actually not kind of hurting my eyes, so it actually lowers it a bit, so that's kind of good. So then we put it, change the duty cycle, and that's going to change. So then the case F, we ask for a value between 262 and 494 that will be taken through the serial terminal to the Bluetooth module and stored in this value, and then we're going to manipulate that value in order to obtain the SysTick reload value for that DAC, and we're going to convert it using this function here, which will turn that digit into a string, and then we're able to output that string using UART1, which will transfer the data from the first microcontroller onto the second. And I have this extra R here in order to, it's just a random value to let it to exit the indec function. And over here, it's essentially, this is the code for the second microcontroller. As you can see, it's going to look in here to take that data value until it sees the stop character, store that value, and it's going to change the frequency. Down here, I also wanted to show you that I have this is the command mode, or AT mode, of the Bluetooth module. This is kind of how I programmed it in order to change the name and the baud rate and the password and set it as a slave down here. I can actually show you if I look in here. It should show I am paired to Albert, which is the name that I had originally set here. The password was changed as well. And just to show you, I have the serial terminal here, which I will start at 57600 because that's what the value was changed to. And if I restart these, we'll see that the project shows up on this serial terminal that is connected via the Bluetooth in UART 5. So here I have the Bluetooth module that runs into the first TM4C, and if we're going to tell it to change the PWM value. So we have this LED here that's light up blue. If I go ahead and type something like 10, the LED should dim significantly because it's almost low. If I go ahead and put in B0, enter, I should turn off the LED. And if I do something like B255, LED comes on all the way. So that is communicating again between this serial terminal using UART 5 to the Bluetooth module into the first board. And then for the second part, we're going to change the frequency. We're going to send the frequency for the DAC data into this board from the first one, and then pass it on through this DAC here, and onto that speaker over there should change the pitch of the speaker. So if we hit F, you will see that it'll ask us for a value between 262 and 494. So if we go to 262, enter, the speaker over there begins playing that frequency of a note. You can hear that it's pretty low. I believe it's a C at this point. And then if we go ahead and hit F again, and then hit 494, which is the max value, you will hear that the pitch is actually significantly increased. I hope you can hear that through the phone. And let's go for a value in between just to show that it actually works in between, something like 350. Just like somewhere in between. And yeah, so that's running, getting the commands from the Bluetooth into the first board, transferring through, that's going from the Bluetooth to the board through UART 5, and then through UART 1 it's going from the first board to the second board, and then outputting all that data through the DAC into the speaker. And yeah, I believe that's the rundown of how this is working. I hope you have a great day.